Hello, myself Sakshi. So firstly I will explain you my minor project, that is AIML assignment project on housing price data analysis. We will explore a real data set, clean it, visualize it, convert categorical values to numeric, perform correlation analysis, build meaningful graphs, and understand what factors affect house prices the most. If you are a student doing an AIML or Python data science assignment, this video will really help you. So let's get started. This project focuses on analyzing a housing dataset that contains 545 rows and 13 columns. The main goal is to understand how different features like area, bedrooms, bathrooms, road access, basement, area, air conditioning, and parking affect the house. We will perform data loading, data cleaning, exploratory data analysis, visualization, feature encoding, correlation analysis, insight extraction. This is a complete end-to-end mini project, data science project. We started importing the required Python libraries we needed for the analysis. This include pandas for data handling, numpy for numerical operations, matplotlib, and seaborn for visualization. Here you can see that we have uploaded the libraries. We load housing.csv file using pandas and display the top 5 rows to understand the structure of the data. We can now see columns like price, area, bedrooms, bathrooms, stories, main road, guest room, basement, and more. We next explore the data set to understand the data types, missing values, statistical summary of the numerical columns. The data set has no missing values, which makes our work easier. It contains 6 numerical and 7 categorical features. To get an overview, we plot histograms for all numeric columns. These histograms help understand the distribution of area, price, bedrooms, bathrooms, and other numeric features. Next is the heat map. We convert yes and no features to 1 by 0. And for furnishing status, we convert categories into numbers. Price has highest correlation with area, bathrooms, air conditioning, number of stories also strongly influence price. Parking and bedrooms also show moderate impact. We create scat plotlibs to visualize how price changes with area and bedrooms. We also use box plots to detect the outliers. We use also that is pair plots. To visualize relationship at once, we use Seaborn pair plot. From our complete analysis, we can conclude the following key sites. Most important features affecting price, area, number of bathrooms, air conditioning, number of stories, parking availability, bedrooms, preferred location, hot water heating, basement. This brings us to end of our AIML assignment of housing data analysis. I hope this detailed explanation help you understand how to perform data cleaning, visualization, encoding, and correlation analysis in Python. So this was my minor project, housing data analysis. Next move forward to my major project. So firstly, on terminal type Jupyter Notebook. Then the Jupyter Notebook will get opened and display this screen. My major project is loan detection using machine learning. This project aims to predict whether a customer will take a loan or not based on their demographic and financial attributes. I will walk you through the problem statement, dataset overview, exploratory data analysis, data preprocessing, machine learning models, performance metrics, final outputs, and saved model. This explanation is designed exactly like a project Viva. This is a supervised machine learning classification problem. Our target variable is target, where 1 is customer accepts the loan, 0 customer does not accepts the loan. The project uses Python, Pandas, NumPy, scikit-learn, Matplotlib, and Seaborn. The purpose of this project is to build a machine learning model that can accurately classify customers and help financial institutions understand who is more likely to take a loan. We load the dataset loan underscore detection underscore process.csv. It has rows 41,188, columns 59, contains already pre-processed and normalized features. Target column is target. Columns include age, campaign interactions, job category, marital status, education levels, contact communication type, month and day of call, previous marketing outcome, housing loan, personal loan, default history. Most categories are already one hot encoded. That's why we have 59 columns. We first check the top rows using df.head and overall structure using df.info. Observations. No missing values. Most columns are float type. All features are scaled. Mean is equals to around 0. STD is equals to around 1. We can also check the target distribution. 39,673 customers accepted the loan. Only 1,515 rejected. This means the dataset is highly imbalanced. Approximately 96% of customers belongs to class 1. We can see that in this target distribution. Data preprocessing. Even though the dataset is already pre-processed, we apply preprocessing pipelines to maintain clean workflow. Numeric preprocessor. Missing values replaced using median. Standard scaling. Converts data to zero, mean and unit variance. Categorical preprocessor. Missing values replaced using most frequent. One hot encoding creates dummy variable. Drop first avoids the dummy variable trap. However, in our case, the dataset contains no categorical columns. Everything is numeric because preprocessing was done earlier. Still, the pipeline remains stable for future raw datasets. Train test split. 80% training, 20% testing. We ensure stratify is equals to y to keep the class proportions consistent. This prevents biased training due to the heavy class imbalance. We train three different ML models. First is logistic regression. Works well when classes are linearly separable, lightweight and fast, good baseline and model. Random forest classifier. Enhanced multiple decision trees, handles large features, sets well, high accuracy and robustness, works well with noisy data. Third is gradient boosting classifier. Builds trees sequentially, focuses on mistakes of previous trees, very powerful for structured data. So the result is accuracy is 100%, precision is 100%, recall is 100%, F1 score is 100%, ROC AUC is 1.0. Why perfect accuracy? Dataset is extremely imbalanced. One hot encoding created very clean feature boundaries. Many numeric columns clearly separate classes. Pre-processed features makes the classification task easier. So confusion matrix shows zero false positiveness, zero false negatives, and perfect classification. ROC curve that is 1.0. The curve touches the top left corner indicating perfect separation. We use grid search CV to tune random forest parameters. Now at the end, we have to save the following files: loan underscore model underscore best, loan detection underscore preprocessed underscore CSV, classification underscore report text ROC curve report.md. These files can be used for deployment, web interaction, Streamlit Flask apps, future model training, etc. To conclude, this project demonstrates how machine learning can accurately predict customer loan behavior. We performed exploratory data analysis, data preprocessing, train multiple models, tune hyperparameters, and finally save the best performing model. This workflow is professional, scalable, and deployment ready. So these were my two projects. First was housing.csv, that is my minor project, and next was loan detection system.csv, that was my major project. Thank you.